There are so many things to derive in a trapezium, and that's the reason we have one more video on trapezium. And in this video, we'll derive an interesting result related to area of trapezium. So the area of this blue triangle in the trapezium is given as 25 units, 25 square units. Area of this red triangle is 16 square units. And we have to find the area of overall trapezium ABCD. Let's use some variables so that we can be a little bit lazy and we can avoid writing these lengths again and again. A, B, C, D, AO again and again. So length of AB I am taking it as X. Length of CD is Y. And this height, this red triangle has a height of L units. This blue triangle has a height of M units. From this point O to this point E, and this point is F. So OE is M and OF is L. And for the time being, I am calling area of red triangle as R instead of 16. I am taking the value as R. Instead of 25, I am taking a variable B, area of blue triangle as B. Now area of this red triangle R will be equal to half into base, that is X, and height, that is L. Area of this blue triangle would be B equal to half into base into height. Okay. Now these two triangles, the red triangle and blue triangles, are similar. Why? Because AB is parallel to CD. So this angle and this angle are alternate interior angles. And this angle will also be equal, alternate interior angle, and AOB and DOC are equal because they are vertically opposite angles. So all angles are equal, these triangles are similar. In similar triangles, what are the things that are in same ratio? Well, this will help you out. The sides, the medians, the altitudes, the angle bisectors, and even the perimeters are all in same ratio as ratio of square roots of area of triangles. Why square roots? Well, this we have seen in similar triangles that ratio of areas of two similar triangle would be equal to ratio of squares of corresponding sides. This we have seen, and this result is what I will apply here. Ratio of corresponding sides, that would be x upon y would be equal to ratio of altitudes, that is L upon m, which will be equal to ratio of root of areas, that would be area of this right triangle is R, root of R upon root of B. From here I can say xm is equal to yl. Okay, this thing I am going to use later on in the question. Now let me write area of trapezium ABCD. What would that be? Half into sum of parallel sides x plus y into distance between them, that is L plus m. Open the brackets and we'll get area as half XL plus half XM plus half YL plus half YM. Half XL is nothing but R, half YM is nothing but B. So in place of this I can write R, in place of half YM I can write B, and XM is equal to YL. So half XM plus half YL will give us one full XM. Okay, because YL is also XM, half XM plus half XM is 1 XM. And in place of X, I am going to write Y into root of R upon root of B. Right, from here I can say X is equal to Y into root of R upon root of B. So X is Y into root of R upon B into M. Okay, and Ym from here is nothing but 2 times B. Ym is 2 times B into root of R upon B. Root b will cancel out b in the numerator, giving us root b in the numerator. So this is 2 times root of rb. Okay. This middle part we have solved it and we have got 2 times root of rb. So area of trapezium comes out to be r plus 2 times root of rb plus b. Okay, which is nothing but root r plus root b ka whole square. Root r plus root b whole square. This is a direct result. This is an important result that you can remember. Next, we have both these areas, area of triangle AOD equal to area of triangle BOC. Both these areas would be equal. Why? Because this triangle DAC and triangle DBC will have equal areas. Both the triangles have equal base, same base DC, and they are between same parallel lines AB and CD. So for triangle DAC and triangle DBC, areas will be equal. Okay, their height is same and their base is same. So both the triangles will have same area. And in both the triangles, triangle DOC is common. This blue part is common in both DAC and DBC. So if I remove this blue part from both the triangles, I'll get this white part to be equal for both these triangles. Okay, if this part is W, area of this part will also be W. So in this equation, I can write area of trapezium as W plus W, sum of these white areas plus this red area plus this blue area, plus R plus B. This will be equal to R plus 2 times root of RB plus B. R and B will get cancelled from both the sides. 2W will give us 2 times root of RB, 2 and 2 will get cancelled, and if I square both the sides, I'll get W square is equal to RB. One more important result that you can keep in mind. So this was the first result and this is second result. So for this question, area of trapezium ABCD will come out to be root of R. R is 16, root of R will be 4. This will come out to be 4 plus root of B. Root of B will be root of 25, that is 5 whole square. 4 plus 5 whole square will give us 81 square units as the final area of this trapezium. Thank you.